Section 6.5. Our objective today is to solve equations containing radicals. So we are looking today at equations such as the square root of 2x plus 1 equals 5, or say 3 plus the cube root of x equals 5, or something like x minus the square root of x minus 1 equals 3. Those are all what we would call radical equations. Right. The process here, the steps that you want to use are: number one, you must isolate a radical, or the radical if there's only one. Step number two is to eliminate the radical by either squaring or cubing both sides. Number three, solve for x. And number four, check solutions. Okay, so in these equations you always have to check your solutions. Alright, so let's start out with our first example, number one. So I have the square root of 2x plus 1 is equal to 5. Step number one, isolate the radical. And this is the radical. It's all by itself on that side. So step number one is 2. Step number two is to eliminate the radical by raising to the same power as the index. And in this case, the index is 2. So I'm going to take the square root of 2x plus 1, and I'm going to square that. But if I do that to that side, I have to square the other side. So when I square this side, then all I get is what's inside the radical, so 2x plus 1. So in other words, the radical cancels out, and so I get 25. And now it's just a matter of solving for x. So subtract 1 from both sides. 2x equals 24. Divide by 2. X equals 12. But now we have to go back to the original equation and check it. So is 2 times 12 plus 1 equal to 5? So 24 plus 1, square root of 25. So 5 equals 5. It checks. So our solution is 12. All right, and the reason that we have to check is because when we do the process of squaring both sides, as we did right here, sometimes solutions are introduced that are false solutions. So we have to always check our work, right? Number two, so I have 3 plus the cube root of x equals 5. All right, now in this one, the radical, first step is to isolate the radical. So I want to get this all by itself. So I'm going to subtract 3 from both sides. Okay. Then now the radical is isolated. Next step is to get rid of the radical by raising to the same power as the index. The index is 3, so I'm going to raise both sides to the third power. So when I raise to the third power, this cancels the radical, so I'm left with just x, and 2 cubed is 8. So now to check, come back to the original. So 3 plus the cube root of 8, is that equal to 5? So 3 plus cube root of 8 is 2. It checks, so our solution here is 8. Okay. Example 3, x minus the square root of x minus 1 equals 3. All right, so again, step number 1, isolate the radical. So on the same side of the radicals, I have this x and I have this negative, so I have to get rid of both of them. So I'm going to subtract x from both sides. So I get negative square root of x minus 1 equals 3 minus x. And then I'm going to multiply everything by negative 1 to get rid of that negative. So I get square root of x minus 1 equals x minus 3. Because when I distribute this, the 3 becomes negative and the x becomes positive. Now my radical is isolated. So the next step is to raise both sides to a power equal to the index. So this power cancels the radical, so I get x minus 1. But on this side, I'm going to have to FOIL this out. Because remember, we cannot distribute the power inside because of this minus sign right here. So I have x minus 1 equals x squared minus 3x plus 9. Because of this x squared, I think I'm going to have to probably set it equal to 0. So let's simplify first. Now subtract x from both sides and add 1 to both sides. So I get x squared minus 7x plus 10 equals 0. So now we're going to factor. So what multiplies to 10 but adds up to negative 7? So it's going to be negative 5 and negative 2. So it's x minus 5, x minus 2 equals 0. Set each factor equal to 0. So I get x equals 5 and x equals 2. Now we have to check our solutions. So remember that the original problem was x minus the square root of x minus 1 equals 3. So if I put 5 in, I get 5 minus square root 4 equals 3. Square root of 4 is 2. So I get 3 equals 3. So 5 checks. So now I go back and do the same thing with the 2. So is 2 minus the square root of 2 minus 1 equals to 3. So 2 minus the square root of 1 equals 3. 2 minus 1 equals 3. 1 equals 3. Not true. So I reject the 2. And so my only solution is 5. All right, next example. Notice this example. I have 5x equals 1 plus x square root 3. Now, what is different about this one compared to the previous 3 examples? Well, the key here is that notice that the variable is not underneath the radical. So in this case, we do not have to square both sides to solve. What we do is we get everything with the variable on one side and everything else on another side. So I'm going to subtract x square root 3 from both sides. So I get 5x minus x square root 3 equals 1. Then notice that I have a common factor of x. So I'm going to factor out that x, and I'm left with 5 minus square root 3 equals 1. Then I want to get x by itself, so I get rid of this by dividing both sides by this. So I get x is equal to 1 over 5 minus square root 3. Okay? But remember that we can't leave that radical in the denominator, so we multiply top and bottom by the conjugate. So I get 5 plus square root 3 on top, and on bottom I get 5 times 5 plus 5 square root 3 minus 5 square root 3 minus the square root of 9. So I get 25, this adds up to 0, minus 3, and so I get 22 on the bottom. So this is my solution. And I don't need to check it, because remember I did not square both sides to get that solution. So that will be the answer.